Hello everybody and welcome to Lab 2. Today we are going to be doing the lab entitled Energy and Matter. And in this lab we will be preparing a heating curve and a cooling curve, as well as determining or using the specific heat of water to calculate heat lost or gained by a process. And then we will be additionally calculating the heat of fusion of water and determining the freezing point of a substance called salal, which is an alcohol of the salicylic acid family. This lab is normally intended to take 2 hours, but the video is not going to be 2 hours long because that 2 hours is meant for you to try and fail a couple times to do the experiment correctly and then have me help you, but I'm going to do it right the first time. So make sure you watch the whole video because there are details throughout both the lecture portion and the experimental portion that are important for the completion of the report. Safety features for this lab are being careful with boiling water and using mitts or tongs to move hot beakers. I will demonstrate that on the video, so you'll get a chance to see what I mean by using tongs to move hot beakers if you didn't already know. And the topics covered will be changes of state, heating and cooling curves, heat of fusion, heat of vaporization. Although there's not an actual laboratory component for heat of vaporization, but it's included in the discussion. So the chemical concepts discussed are ones that we talked about in class. The heating curve for water, where you measure the temperature increase and phase change behavior of water over a range of temperatures. Temperature is related to the kinetic energy or energy of motion of the molecules in a substance. And when water molecules gain heat energy, they move faster and the temperature rises. Eventually, the water molecules get enough energy that they break away from the liquid and form a gas. And when this happens, the temperature will plateau and become flat. So you'll observe this in part A of the lab. You'll heat water up to its boiling point and then watch it boil with a thermometer in it and I will record the temperature, but you'll see the data and manipulate it. So this is a rather poor picture, but it's pretty good resolution in the PowerPoint presentations. So if you want more details, look there. In part B, we're going to be measuring a cooling curve. So this substance, salal, melts at a intermediate temperature significantly below the boiling point of water, which allows us to melt the solid in hot water and then let it cool back through its freezing point and observe that behavior. So we're going to observe the process of the particles in the liquid slow down until they freeze and become stationary, which is when it becomes a solid. And then at this point, the temperature will also become constant and form a flat line. However, if you look at figure 2 here, sometimes during the cooling of a solid, it will cool below its freezing point briefly and then increase in temperature as it freezes. And then that temperature will become stable, and it will, after a while, it will start decreasing in temperature again. So this is not always observed, but if you have a very steady cooling process without a lot of outside influence, sometimes it can do this. And then in part C, we're going to look at heat of fusion, which is the amount of heat it takes to melt a solid. So ice melts at 0 degrees Celsius, and the heat of fusion of ice at that temperature is the amount of heat that's required to melt 1 gram of it. So what we are going to do is measure the heat required to melt ice by measuring how much that process decreases the temperature of liquid water. And we're going to do that by having liquid water at a known temperature and ice, which is at 0 degrees, and we're going to put the ice in the water. The water will melt the ice and go down in temperature, and that temperature decrease is directly related to the heat lost, which is equal to the heat gained by the ice. We divide the heat that we've calculated by the mass of the ice, and that gives us the heat of fusion. And just for completion, the heat of vaporization is a similar process. You could do that same process for liquid to gas. However, you would need a container to capture the gas in so that you didn't lose any, because otherwise your mass would be incorrect. We don't have the setup for that here, so we're not going to do that. So, on to the experimental procedures. This is one where goggles would actually be recommended because boiling water can get in your eyes. However, it's still a fairly safe lab to do. For the first part, I used a 250 milliliter beaker on a hot plate with a thermometer attached to a ring stand inside of the beaker. And I'll be showing this in the video. Then I took a graduated cylinder and poured approximately 100 milliliters of cool water into it. In this case, I got it to be 95.5 milliliters. And then I poured it into the beaker. Its initial temperature was 21 degrees. And after turning on the hot plate and starting the stopwatch, we record the temperature in 1 minute intervals until the water reaches boiling, and then for 4 minutes afterward. Okay, so we have a graduated cylinder filled with approximately 100 milliliters of water. And if you look at the meniscus, it's 95.5 milliliters of water. Now, we dump the water into the beaker. We adjust our temperature rod so that it's just off the bottom. And we give our water a chance to settle. But we notice that the water is also 21 degrees. We turn on the hot plate. Just want to go down to it real quick. Put it all the way up to the top. Now go back up. We're going to click the stopwatch. Is it in focus? One minute. It is 24.5 degrees. Did you stop it or keep it going? I guess it doesn't matter at this point. Just keep it going.
I was going to film some of the water.
And I would say just keep it focused on the temperature at this point.
Okay.
As much as possible.
There. Oh. There we go.
It's 2 minutes. Temperature is 33.
Wow, it's climbing.
$43. Decided to put it on as high as possible because I don't want to be waiting around. Wow, that's going really fast.
It's already at 55. There you go.
57, 56 and a half.
Oh, wow.
It's at 4 minutes. Part of me wishes we'd brought the second battery and kept it charging while we were working, just in case this one dies.
It's full battery.
Okay.
Yeah, it's fully charged.
I know, I just always worry.
Not gonna lie, on the way over, I was like, I should have grabbed it.
5 minutes. We are at 73 and a half.
I'm definitely gonna have to move this up.
We've got steam. Bet you this boils within the next minute. It is cruising.
Where does the chair go? Oh, I bet the chair goes up too. That's a lot of pressure.
Yeah, don't do it right now.
No, I'm not going to. I wanted to see if it would.
It's not quite boiling yet.
And I wanted to see the pressure.
6 minutes is at 89 degrees.
Oh, well.
Okay. At 6:45, it is boiling. Do you see the boiling? Now we're going to keep it boiling for 4 minutes or so. technically reading 103 degrees. I'm only going to 10 minutes. I'm almost to 8:30 right now. Hundred and three. Hundred and three. All right. Now scroll down to this. All right, and then scroll back up to the boiling water. And wait for it to stop boiling and then hit the record button again. In fact, we'll get 1 more minute marker just because it's still at 103. Okay. We good. All right. All right. Now that we've collected the data, we're going to go into how you make the heating curve. So I have collected the data in Google Sheets that will be attached to the Google Classroom assignment. So it's entitled Experiment 2, Energy and Matter. Experiment 2 Data is the title of the sheet. Here for part A, you can see I have a time in minutes. I have a temperature in degrees Celsius. And I've recorded the volume of the water as 95.5 milliliters. Now your assignment is to graph temperature on the y-axis as a function of time on the x-axis and observe the behavior of the resulting line. Obviously, it increases over time and then reaches a constant value. But I'll let you discuss that further in your report. Just as a review of the math, so you graph it. The plateau of the graph is where the boiling point is. This is what you're going to record in your lab report. And then you will also use the graph to determine the temperature change from starting point to ending point. And then once you have that temperature change, you know the volume of the water and you know the density of the water, so you can determine the mass of the water by multiplying the volume by its density. And then you use the heat equation to calculate the heat required to heat the water to boiling. So the number of joules is equal to the mass times the temperature change times 4.184 joules per gram per degree Celsius, which, as we know, is the specific heat of water. Now, and I'll just show you really quick what that looks like on the lab report. So part A, you're going to provide me the boiling point of water. You're going to provide me the temperature change. You're going to provide me the mass of water. And you're going to provide me the joules. And to show your work, just type out the heat equation, substitute in the values, and then provide the answer in the blank to the correct number of significant figures. Now, part B is the cooling curve. So for this one, it's going to be a little bit of a different setup. We have a bigger beaker that's going to be half full of water. We're still using the hot plate, but we're going to have something called the freezing point apparatus, which is a large test tube with a little bit of this compound salol or phenyl salicylate. It's going to have a stopper and a copper stir rod and a thermometer in it, which will be frozen in place by the solid salol. Then I'm going to heat it up to 70 degrees Celsius, and we will observe it go from solid to liquid. And then we will start the timer once it reaches 70 degrees, and I take it off of the heat. Still read that, right?
Yes. Go for it.
We're turning it up halfway because we don't want the heat to go up as much for this one as we did before. And we are waiting for this stuff to melt, so maybe just stay focused on that.
There.
Interesting. Sorry, is that as close as it goes?
Yes.
Okay. If I slide. You can see it starting to melt because the bulb of the thermometer is becoming visible. We have to increase the temperature a little bit.
So what is that substance?
Salol.
What is salol?
It's like an alcohol of salicylic acid.
Ooh.
This is 220.
Do you want me to stop since it's melted?
No.
Go up to the temperature.
Okay, yeah, I guess you can go up to the temperature now. We gotta get up to 70. So what I'm going to do when this hits 70 is I'm going to pull it up out of the water and swing it out and start the timer.
Okay.
So that's what this part describes. This part describes heating it up to 70 degrees Celsius. The important thing for this is to not boil the water because it will also boil the salol and can have some problems. The initial temperature ends up actually being about 71 degrees, and you can visibly watch the thermometer go down as we cool. And I'm holding the stopwatch in front of the camera so that you can see the time as it clocks in. And near the end, we will watch the solid form again as it passes through its freezing point, and you'll notice a dip below the freezing point, a supercooling phenomenon where the temperature goes low and then increases again as the solid forms. Is it zoomed all the way in?
No.
All right. So now I lift. Can you see the number?
No, because you lifted it up. Here, I'll bring it up.
Right there?
I'll bring the camera up to it.
Okay.
There.
All right.
It's good. It was in focus. I'm just watching it. Because this is what I do.
We're at 60. It was 68.
Yeah.
Once it starts to freeze again, I will have you shoot down and look at it. And we'll go back and forth. We're at 63. It's 57.
Mm-hmm. That's good.
53. Okay, good. It's going down by about the same amount every time.
Cool.
We're going to start it again.
How far do you want to go down until?
We have to go till it freezes and then wait 5 minutes.
Oh, it freezes again.
Yeah.
Ooh. That's fun.
$49.
I'm gonna have to bring this down. Oh. Wanted me to finish it off the bottom. I'll wait until after you do that.
We're down to 45.5. I will call it 45. Are you looking at the actual temperature?
Yeah.
Temperature readings on there.
I thought you had said getting both back
Right,
and
it's
forth.
not actually frozen yet. So we're at 42. I'm feeling it's going to start solidifying soon.
I'm gonna have to stop it and start recording again. Because it'll time out on us, I think.
I thought it was 15 minutes.
That shows it has 8 minutes left in this section of recording.
Oh yeah, that's fine. I think we'll be done by then.
Okay.
Eight. 40. 38. Whoa, it's getting more viscous.
Would you like me to go down to it?
Yeah, you can start. Well, yeah.
6
Let me
minutes.
get this last measurement and then you can go down to it.
Okay.
We're at 37 and a half. Can no longer stir it because the thing is frozen in place. Cool. This is exactly how much. This is literally going to run. This is going to end when we need it to end.
Awesome. So I don't need to touch it. Cool.
Still 39 degrees.
That's so interesting.
Right. If I do this right, we'll probably be out of here by 3. A little after, maybe.
I got a thing on. It's going back in my pocket. A little lint friend.
It's still 39.
Do you want me to go back up to the temp? Between the two?
Yeah, go just look at the temp now. For this last measurement, for the second to last minute. I might have to get a shorter, like a desk tripod. In addition, like, because this one would be too tall.
Yeah.
That way we can get like real close.
I think that would be good.
only need one more temperature reading, so what we'll do is we'll get the temperature reading, we'll scroll back down to the solid, and then that'll be it.
Okay. My uterus is cramping. It's uncomfortable.
What?
My period cramps. That sounded fun.
It was delicious. It's still 39 degrees. Cool. So, now scroll down to the solid again. Just like angle it. Don't even bother scrolling. Oh, too far. Alright. I'm actually going to go check this. No. Okay.
Here, I can. What is it? No.
Okay. And you can. So now on to. Oh, this is a picture of the apparatus, but you'll see the actual apparatus. Now, plotting the cooling curve for Salal is basically the same process, except the data will be going in the opposite direction. So, back to the Google Sheet. Part B here, there's a time in minutes. There are 15 temperature and time readings, and they decrease this time. So, for the report, the temperature will decrease and then it will plateau. The plateau is the point at which Salal freezes, so that's the answer for part B. Obviously, you also have to make the graph with temperature on the y-axis and time on the x-axis. And then part C, heat of fusion. This part is a little bit more of a complicated setup, but it's a much simpler lab. So we have this thing called a coffee cup calorimeter, where we take a styrofoam cup and a styrofoam cover, not a cardboard cover, and we even put a thermometer through a hole in the top and poured 100 milliliters of water precisely into the cup. After measuring the mass of the cup and the mass of the cup plus the water, we also record the initial temperature, which is 21 degrees. And after that point, we add a handful of ice to cool it down to about 2 degrees Celsius. Once I've done that, the ice is all melted, and we place the styrofoam cup onto the balance again to measure its mass and see how much ice was added. And recording the final temperature of about 2 degrees gives us all of the information we need to determine the heat of fusion of water. Zero grams. Now, take my cup. Alright, put it on there again. 6.988 grams. Alright, now milliliters, pour into the cup. Take the mass again. Look at the mass now. 106.250. All right, now take this out. Calorimeter. And let's actually move it. Wait, change the one. Is that better?
No, I can zoom in though, and it'll get it.
$21.
Mm-hmm.
All right, now
Jeez.
might have added too much ice. Don't matter. Now you can actually just turn off the video now.
It's now recording.
Can you see the zero or the temperature?
Turn it to my left a little bit, slightly. There.
Can you actually read the number?
Yes.
Okay, so it says to me that it is 2 degrees Celsius. All right. Now we will take this out and that out.
Stop recording?
No. Rotate it over. Right, and now see if we can get that number. Okay, 133.833. Cool. We're done. So, the data is, again, here in the sheet. The mass of the cup is 6.988. The mass of the cup plus the water is 106.25. The initial temperature is 21 degrees, and the final temperature is 2 degrees. And the final mass plus the ice is 133.833 grams. So from that information, you can answer the questions for part C. Mass of the calorimeter plus water, initial water temperature, final temperature with the ice, final mass with the ice. And then the things that you actually don't know already, mass of water, which is the mass of the calorimeter plus the water minus the calorimeter, which leaves you with just the mass of the water. The temperature change is obviously the final temperature or minus the initial temperature, so it's a negative temperature change. And then the energy lost by the water is found with the heat equation, so type out the heat equation, substitute your values, and then give me the answer. Then the mass of the ice is 5 minus 2, so line 5, mass of calorimeter plus water plus ice, minus mass of calorimeter plus water. This gives you the mass that you need to calculate the heat of fusion, where you divide the joules from 8 by the mass from 9, showing your work and giving me the correct answer.